In this example problem, we're going to be an organic food store. And while we sell a variety of products to our health-conscious consumers, we have one particular product line, our chef-designed meals, that we are witnessing has steady sales growth over time. For the purpose of planning, for making predictions about the amount of sales revenue we expect to generate in the upcoming weeks, we are going to analyze this information which is provided to us to determine, firstly, that there is in fact a linear trend, which would signify that stuff is going up, sales is going up over time. And then secondly, to use the data analysis toolpack's regression mode to be able to make forecasted predictions for the upcoming 4 weeks. So let's start by filling in our scatter plot, just to visually confirm to ourselves that there is a linear trend in this information. And what I can do is just highlight all of my information, week in sales, the way that it's presented, and I have the full year, and they're all 52 weeks. I can go to Insert, and I can go to Scatter Plots, and I think I'll take the one with the lines in it just because it does a better job of conveying the trend that we have going on over here. And there's our sales for the last year. And if we want to be fancy, we can go in and we can label all of our axes, which would be perfectly fine, but I'm just really more into making sure that there is in fact a linear trend going on here. So I'm going to go down to the trend line, and I'm going to go to more options, and let me slide this over just a little bit so I can see it. Put on my different things underneath with the R squared showing. That's like 0.7538. You got a 6.2 here. That one's not quite as high, though it is close for exponential. Polynomial, no, but it's not getting it done either. There is a linear trend, without question, going through the middle of our information. So since linear regression is appropriate in this case, we can use the data analysis toolpack to figure out what is the formula that we can use to predict revenue generated during the upcoming month, the next 4 weeks, which would be weeks 53 through 56. So I'm going to go to the data analysis toolpack. I'm going to pick regression. And then for my ranges in here, X makes Y change. And what we're saying here is the more weeks that we have, the further time goes on, our sales keep getting higher and higher and higher. So the time is making our sales change. So for our Y range, I want the entirety of column B. I don't know why it's not working for me. So all the way down to B53. And for the X range, I want the entirety of column A. So I should be looking a little something like that. I did have the labels on, and I want to have the output be underneath this information. So I'll put it right there and cell D20, and I'll hit OK. Voila, we've got our regression model going on over here. And what our regression model is telling us in this case is that baseline, when we started, our sales were about 2,000. Not far off from what we started with up here. That number looks pretty good. And then as time passes, each week our sales of these chef-designed meals have been increasing by about $97 per week, which makes my regression equation 1998.23 plus our coefficient for week. And let me just make this roll a little bit bigger so you can see it all. There we go. So that is going to be our assumption. Basically, this is where we started, and then every week our sales are going up by about $97. How good of a predictor is this? Well, what's the R squared? Just the regular R squared of our model in this case. It's going to be equal to this guy right here, rounded off 0.7538. So what are our forecasted sales then for the upcoming period? Well, it's always going to be equal to the amount that we have as our baseline, plus, in parentheses, the coefficient for week, times the week number. And the next week we would be predicting for is our 53rd week in our data set. So during week 53, in this case, we can predict that we're going to generate $7,130.66 worth of sales revenue from the sale of these chef-designed meals. And then rinse, repeat. It's going to be the same thing all the way down the line. We're going to have it be our constant plus our coefficient for weeks times the week that we're predicting for. The second one will be for 54, bringing up our sales by, somewhere in the ballpark of that 90 some odd dollars that we thought, up to $7,227.49. During week 53, we would take our constant, add to it the product of our coefficient for the number of weeks and the week that we're testing for, which is 55. And we see our sales are expected to jump to $7,324.33 during week 55. And then lastly, to wrap up this problem, we would take our constant and add to it the product of our coefficient for weeks times the last week we're predicting for, which is week 56. And that comes out to be $7,421.17. So our local organic food store right here has pretty good, substance to make the prediction in this case, that our sales are expected to increase by about $90, $96 per week, increasing to these selected values during the next month. And we expect, using this model, that about 3/4 or 75% of all the data points we have are going to hit within that regression line.